We're going to continue talking about angles, and today we're going to talk about something called arc measures. We are going to talk about arc length and the area of a sector. Both of these are things that you've done in geometry before, so we're going to move pretty quickly through them. Arc length is the length around a circle like this. So it's this distance here whenever an angle opens. So if we have an angle that has this initial side and then it opens some amount of degrees, some theta, and we know the radius of that circle, we can find the length of that arc. This is called an arc, and it's a capital letter S. Arc length equals the radius of the circle times theta. And the only thing we have to make sure of is that our theta is in radians. Okay, so this is arc length. It's the distance around the circle based on how wide the angle opens. Our other formula that we're going to learn is to find the area of a sector. A sector is whenever you have a circle and you have a radius as the initial side and your angle opens some theta. Well, the area of the kind of fan shaped wedge there is called a sector, and the area of that sector is area equals 1/2 r squared times theta. So you just need to know the radius and the measure of the central angle, and we can figure these things out. So find the arc length and area of the sector of the circle with radius r and central angle theta. So we have a circle. And within that circle, we have a radius of 6, and we have an angle that opens, and that angle measurement is pi over 6 radians. And we'll learn more about what that actually means as we move along. But we want to find the arc length. That means we want to find this distance from the initial side to the terminal side along the circumference of the circle. So arc length equals radius times theta. And go ahead and write arc length up here. So when you're looking back to do your assignments and to study, you know this is how we do arc length. So our arc length equals 6 times our radius, our angle in radians. So 6 times pi over 6. So our arc length, 6, 6. So our arc length is just pi. And normally this would have a measurement centimeters or inches, but it doesn't, so we're just going to use centimeters. And that's also equal to 3.14 centimeters. So depending on how you're supposed to leave your answer, either of these could be the correct answer. Now when we do our sector area, we're going to use the formula for area. It's 1/2 r squared times theta. It should be an A. Area equals. So A equals 1/2 6 squared times pi over 6. And you can simplify this a lot of different ways. The easiest way I see is that 6 squared over 6 just makes 1/6, because this is 6 times 6 over 6. So 6 times 1/2 is 3. So this all equals 3 pi. So the area is 3 pi, and it would be centimeters squared, and that's approximately equal to 9.4 centimeters squared. So again, depending, rounded or exact, which answer you need. All right, example 2, find the length of the arc and sector area of a circle of 2.5 feet radius intercepted by a central angle of 225 degrees. So here's my circle, radius of 2.5 feet. Now 225 degrees is, if you open up from your initial side, 180 degrees plus 45 more degrees. So it's going to look like that. So our arc length goes from here all the way around to here. But remember, we said to do our formula, we need to have our theta needs to be in radians, right? So right now it's 225 degrees. So to switch it to radians, we do 225 times pi over 180. So that gives us 225 pi over 180, which you can reduce pretty easily to 5 pi over 4. So that's what theta equals, and that's what this angle measurement is. So if we want to find our arc length, r times theta, so arc length equals 2.5 times 5 pi over 4. So our arc length equals, you can use your calculator to figure this all out, 25 pi over 8, and that is also approximately 9.8 feet. So this is 25 pi over 8 feet and 9.8 feet. So either one is the correct answer. Okay, area equals 1/2 r squared theta. So that's 1/2 times 2.5 squared times 5 pi over 4. All that can go right in the calculator, so we get 31.25 pi over 8, because 2 times 4 on the bottom is 8. And that's going to be feet squared. We can reduce that using the calculator to 125 pi over 32 feet squared. And we can approximate it also in the calculator to 12.3 feet squared. So our area equals either one of those. Not so bad. All right, we're going to step into the world of physics for just a second and talk about something called linear and angular speed. So suppose an object moves along a circular path that has a radius r. So that means we have a circle, it has a radius, and we have this thing that is moving along the circle. Well, if s is the arc length, which we know, traveled by the object, so the arc length is the path it travels during a time t, then the object's linear speed, v, is given by this equation. So v stands for linear speed. Also velocity is what you're used to. So it's the surface, so it's the arc length divided by time. And that should be exactly what you're used to doing. It's distance divided by time, except here our distance is an arc length. Okay, the next formula, if theta is the angle of rotation in radians, so here's theta, and here is our distance traveled. So theta is the angle through which the object moves during time t. Then the angular speed, w, is given by this equation. W equals theta divided by time. And again, this is just like distance divided by time, except it's how far did the angle open. All right, one little thing here, theta in radians. Okay, you get used to that. All right, example 3, the circular blade on a saw rotates 2,400 revolutions per minute. So what that means is we have this saw blade, right? And it's our angle, one revolution, right? That's one time around. Well, 2,400 revolutions per minute means that happens 2,400 times in 1 minute. So our theta is 2,400 times 2 pi. Because if you remember when we talked about radians the first time, 2 pi is one time around a circle. That's why the circumference formula is 2 pi r. All right, so if our theta is 2,400 times 2 pi, that means theta is 4,800 pi in radians. And our time that it takes to do that 4,800 pi is 1 minute. All right, we're finding the angular speed. So angular speed, we need the theta and the time, which we have. So our angular speed equals theta divided by time. And we already know what those two things equal, so our angular speed equals 4,800 pi divided by 1 minute. But when we read here, it says radians per second. So we got to convert from radians per minute to radians per second. So 1 minute and 1 minute cancel each other, and we have 4,800 pi over 60, which we can simplify to 80 pi radians per second. And that's approximately 251.3 radians per second. So again, depending on what we need to do with our answer, there's both versions. All right, last one. The blade from example 3. So this blade has a radius of 4 inches. So now they tell us a little bit more about the blade. That's 4-inch radius. Find the linear speed. Well, the linear speed is arc length divided by the time it takes to travel that distance. So arc length, if we remember, is radius times theta. So that's 4 times, so we already know theta is 4,800 pi. So that is 19,200 pi. That's our arc length. So our linear speed is 19,200 pi per 1 minute. But again, we want inches per second. So we're going to multiply by 1 minute for every 60 seconds. 19,200 pi over 60 seconds equals 320 pi radians per second, which is approximately equal to 1005.3. Sorry, this isn't radians. This is inches. Because this up here was inches, right? Because our radius was inches all this time. And that's it. That is angular speed. I'm sorry. Yeah. That is linear speed and angular speed. Have a great night.